Okay, now that you've had some review of scientific notation and you've learned how to multiply with scientific notation, I'm going to show you how to divide with scientific notation. Please make sure you've either printed out the notes template or you do have something to write on, because I'm going to ask you to do a couple things on your own, pause the video while you do that, and then come back and check to make sure you've got a grasp on things. So on each of the examples, we're going to perform the operation given, which will be division minus the first example. We want to make sure that all the answers that we give are in scientific notation when we get to the dividing problems. Like I said before, we will do one example, just doing a check-in basically to make sure you're understanding that scientific notation concept. One thing to reiterate is that negative exponents, normally we always want to fix that negative. The only time that negative exponents are okay is when we are writing something in scientific notation. So before I get started on the new topic, before I get started on dividing, I'm going to ask you to pause the video and try example 1. Okay, now that you had a chance to try doing some more stuff with scientific notation, let's talk about what this is. So the issue that I'm running into is that I have a really hard time comparing all these numbers when, let's see, let me get out of the marker. When I have this number that's written in some crazy form, not standard form because of this times 10 to the 5th, but also not in scientific form because I don't have a number between 1 and 10 here. I have a number that's written in scientific notation, I have a number that's written in standard form, and I have another number that's kind of written in some in-between form, not quite scientific notation because this is not between 1 and 10, not quite standard form because of this times 10 to the 3. So the way I'm going to fix that is I'm going to put all 4 of these in the same form. So because I think it's good practice to see scientific notation, I'm going to put them all in scientific notation. So in order for my first number here to be in scientific notation, I'm going to have to move the decimal back three places. So I have a number, 6.3, that is between 1 and 10. Times 10. If I move the decimal back, I have to subtract. So instead of 10 to the 5th, I'm going to have 10 to the 5 minus 3, which is 10 squared for my first value. My second value is already in scientific notation, so I'm just going to rewrite it. My third value, if I want to put that in scientific notation, excuse me, I see it as a big number, so I know my exponent is going to be positive. I need to put the decimal here between 6 and 1, so I'll have 6.103 times 10. I moved forward 1, 2, 3, so I'm going to do times 10 to the 3rd. And then finally on the last one, putting that into scientific notation, I'm going to move forward 1, which tells me to add to my exponent, giving me 6.31 times 10 to the 4th. Now I can compare. So I see that times 10 squared is going to be my least, since that is my least exponent. So 6.3 times 10 squared will be my least value. My second to least value is going to be here, because now I have a 3 with my exponent. 6.103 times 10 to the 3rd. And then comparing these, they have the same exponent, so I'm going to compare the numbers. 6.03 is smaller than 6.31, so I have 6.03 times 10 to the 4th, and 6.31 times 10 to the 4th for my final answer. Sometimes they'll want you to put them back in the form they were given, so I could either write it like that, or I could say that this was my first smallest, 0.0063 times 10 to the 5th. My next smallest was 6103. My next smallest was 6.03 times 10 to the 4th, and then 63.1 times 10 to the 3rd, depending on what your problem is asking you to do. If it does not specify, you can feel free to put it either your answer in scientific notation or back in the original form. Moving on to dividing. When you are dividing, just like with multiplication you multiplied the numbers first, and then you multiplied your 10 to the n's, for lack of a better word, second. Same thing with dividing. You're going to start by doing the division with your number part, and then you're going to divide your base 10s. The reason is because we know that if we have same base, we've already seen a rule for this. The rule for this tells us that if we have a to the m divided by a to the m, that's the same thing as a to the m minus n. So I'm going to use this on the following examples. I'm going to do the first two, and then once again, I'm going to ask you to pause the video and try the second two. You can use a calculator for this if you'd like. On the first one, 7.5 divided by 2.5. I am going to divide those first. So 7.5 divided by 2.5 gives me 3 times 10 to the 12 times 10 to the 8th is 10 to the 12 minus 8. We always do top minus bottom when we're looking at our exponents. So that gives me 3 times 10 to the 4th. I asked myself, is this in scientific notation? Because the number 3 is between 1 and 10, it is, so there's nothing else I need to do. That is my final answer. Doing the same thing for example 2. First thing I'm going to do is I'm going to do 3.2 divided by 4. I'm going to divide my numbers. That gives me 0.8. Always do top minus bottom, so times 10 to the negative 4 minus a negative 8. Well, that gives me 0.8 times 10. Minus a minus becomes plus right here. So negative 4 plus 8 is positive 4. Then I ask myself, is this in scientific notation? Well, because 0.8 is not between 1 and 10, this is not in scientific notation. In order to get it to be in scientific notation, in order to get a number between 1 and 10, I have to move my decimal back. If I go back, I subtract from my exponent. That gives me 8 times 10 to the 3rd. Now I'm going to give 2 examples for you to try. Please pause the video and try example 3 and try example 4. Or pause the video and try example 3, replay for the solution to example 3, and then pause the video again and try example 4. All right, now that you've had a chance to try these problems, I'm going to do, to begin with, 7.2 divided by 9. That gives me 0.8 once again, times 10, top minus bottom, so 6 minus 4. Well, that gives me 0.8 times 10 squared. I ask myself, is this in scientific notation? No, it's not, because 0.8 is not between 1 and 10. So I move my decimal back. If I go back, I have to subtract, giving me 8 times 10 to the 1, which is the same thing as 8 times 10. Either way you write that is fine. Okay, so same thing with example 4. If you didn't try it yet, pause it and try it first. First thing I'm going to do is 84 divided by 0.4. It gives me 210 times 10 to the top minus the bottom. Well, that gives me 210 times 10 to the negative 8 plus 6, which is 210 times 10 to the negative 2. Remember, scientific notation is the only time that negative exponents are okay, so I'm going to leave that. Now, my my decimal is always in the back if it's not written. So when I check to see if 210 is in scientific notation, I realize it's not because it's not between 1 and 10. I would need to move my decimal 2 times to be between the 2 and the 1 to be a number between 1 and 10. Well, if I move my decimal forward twice, I have to add 2 here. That gives me times 10 to the 0. Well, we know that anything raised to the 0 is times 1. So my final answer is 2.10 times 1. Anything times 1 is itself, so just 2.10 or 2.1 because the 0 at the very end isn't necessary. Now that you've been exposed to both multiplying and dividing, if you look on IXL or on your self-assessment sheet, you can see where you can find some practice on there on each of these individually, or there is also a link on the Moodle or the Gilpin.net account that will lead you to some practice on a mixture of both multiplying and dividing with scientific notation.